into flip-flops. SR flip-flop. SR flip-flop is a circuit which is used to store single bit of data. Here we have three inputs, S, R and Q, which returns the history of the state. Here we have two states, state, set state and reset state. When R is 0 and S is 1 and the Q is 0, it produces output as 1. Likewise, the reset state, if S is 0 and R is 1 and Q is X is equal to 0, then it produces Q as 1. So this is known as the reset state. Let us look into the characteristic table. When the clock pulse, during the first clock pulse, the state and the reset state are 0. The inputs is 0, therefore the present state is 0. The next state will be also 0. During the second clock pulse, the state becomes 1. When we fix R as 1, as we got the previous state as 1, we are getting 0 0. And if we set 0 1, as we got previous state as 0, now we are getting 1 in Q. This is known as the reset state. In the next circuit, as S is 1 and R is 0 and the previous state is 0, we are getting 0 1. This is known as the set state. Let us look into the JK flip-flop. SR flip-flop does not work for the condition 1 1, where it gives error, invalid state. Therefore, JK flip-flop was invented, in which toggle is used using clock signals. Here, when both the inputs are 1, it returns to the previous input. Let us look into the diagram. In this case, up until set state, it acts just the same way as SR flip-flop. Only in this state, it goes to toggle mode, and if we reset the circuit, it functions normal. Let us look into D flip-flop. D flip-flop is a gated SR flip-flop, which is single input flip-flop, and it is also controlled by clock signals. When the input is 0, the output is 0. When the input is 1, the output is 1. When the input is 0 and the previous output is 1, the output is 1. When the input is 1 and the previous output is 1, the output is 1. Let us now look into T flip-flops. T flip-flops are simplified version of JK flip-flops. Here, when we return 1 and the previous 1, it returns 0. Let us look at what do this JK flip-flop returns. When the input is 0, it returns 0 0. When the input is 0 and the previous input is 0, output is 0, it returns 1 1. And if the input is 1 and the previous input is 1, it returns 0 1. And the input is 1 and the previous input is 1, it returns 1 0. In this case, it does not return 0. Whereas in D flip-flop, it returns 0 if the previous output is 1 and the current output is 1. Let us look into the simulation. This is the SR flip-flop. Here, currently, it is in the state. So, 1 reset as 0 and Q is 1, therefore Q complement is 0. Let us look into reset state. Here R equals 1 and S equals 0, and the previous input is 0, therefore we get q dash as 1. If both the inputs are 0, the state we have obtained is the previous state. If both the inputs are 1, the state we obtained is invalid, which means it has both 1 and 0, therefore the output cannot be determined. Let us now look into the JK flip-flop. This is the JK flip-flop. So when the input is 1 0, when the input is 1 0, it returns 0 1. This is known as the set state, as in SR flip-flop. And likewise, it reset state likewise during the reset state we get 1 0, and during 0 0 we are getting previous state, and we give both the inputs, we are getting the previous state. So this is the advantage of JK flip-flop. Let us now look into the D flip-flop. Here this is the input and this is the clock signal which I set to 1. Okay, 1. So when the input is 1 and the previous input is 0, we get 1 0. When the input is 0 and the previous input is 1, we get 1 0. When the input is 1 and the previous output is 0, we get 1 1. Likewise, we can see how T flip-flop works. If the input is 1 and the previous output is 0, then the output is 1 0. If the input is 0 and the previous output is 0, the output is 1 1. If the input is 1 and the previous state is 1, the output is 0 1. Thank you.